In this lecture, we're going to learn about the STD map container. This is an associative container which is going to store key value pairs explicitly. So for example, here we have the ID, which is going to act as our key. This is going to be of int type, and we have a value which is going to be an STD string or a const card pointer, depending on how we can store these things. The key defining feature of STD map is that the data is explicitly split into key value pairs. If you want, you can come to the documentation and learn all you want about STD map here. And if you go down, you're going to find a bunch of member functions you can use. For example, we can use the at method to get a given element at a given index without bound checking. We can use our operator to access an element at a given index within our STD map. And this operator is going to take a key, and we will get the element that is associated with that key. You should really know that. We have a bunch of iterators we can use. We can use begin and end. We can use cBegin and cEnd. And we even have reverse iterators that we can use to traverse our container backwards, and that's going to work. We have capacity method, we have modifiers. We're going to play with all these methods, and we will really have a good picture of how we can play with STD map in our C++ programs. Now, here are a few facts about STD map. It is going to store several key value pairs, and each element really is going to be like an STD pair on its own. STD map is going to store elements ordered by key in increasing order by default, because that's going to be using the std-less functor by default to order the key elements. STD map doesn't store duplicate keys, just like we don't store duplicates in an STD set. So we are ordering by key, so we don't really have business supporting duplicate keys in our STD map container. If you try to put in a duplicate key, the container is just going to ignore you. It's not going to add the new piece of data. Searches for keys is very fast, just like the search is fast in STD set. And the reason is things are ordered, and this is going to be like searching in a dictionary. That's going to be very fast. STD set and STD map share the property that they don't store duplicates, and elements are going to be ordered automatically as you store them in the collection. This is really cool if you happen to need this in your C++ application. Now, to use the STD map container, you will need to include the map header as you see here. And here are a few examples of how you can work with this. You're going to see that we have a lot of similarities with STD set. So I am going to move a little bit faster in this lecture here. So we can create a map of int. Int is going to be a key, and another int is going to be the value. This is how we work with this. And we can put in a bunch of key value pairs, and each pair is going to be englobed by a pair of braces here. This is how we can set this up. So for the first pair here, the first element is the key, the second element is going to be the value, and we can loop through this collection, printing it out as we are about to see. Down here you see that we can set up a map, and the key is going to be an integer, the value is going to be a book object that we put in here, and we can initialize our thing as we see right here by putting in key and value data, and this is going to work really well. Once we have this map called books set up, we can print it out, and this is going to work just fine. Now, let's take a closer look at our print map function. We are going to modify it a little bit to take two template parameters, because STD map needs two template arguments, one for the key and another for the value here. So once we have our map object, we're going to loop through it. Using a bunch of iterators, we're going to set up a beginning iterator, we're going to set up an end iterator, and we're going to loop around checking and seeing if we haven't hit the end iterator. As long as we haven't hit the end iterator, we're going to dereference the iterator and get the first and second data members and print the data in our pair. And that's going to give us key value information. First is going to give us the key, second is going to give us the value, and we're going to access this data and print this out in our C++ program. So this is how our print map function is going to work. We have a bunch of ways we can use to loop through our STD map. For example, if we have our books map, we can loop through using the auto syntax here, and we're going to collect key value information in these key and value variables, and we can print them out, looping through our collection and printing each piece of data at each iteration. This is something we can do. Another way to do this is to do auto type deduction directly like this. And at each iteration, ELT is going to be an STD pair. So we can call first and second and get key value information and print our data. And you're going to see that this is also going to work. Another way is to explicitly say that you will be getting an STD pair object. You're going to call that ELT. And at each iteration, you will call first and second to get key value information and print this out. And we're going to see this printing on our terminal. And again, this is pretty cool. Now, I want you to know that keys don't have to be integers or anything. You can set up keys of any type. For example, here we are setting up an STD map, which is going to take string keys and string values. And we can put in data like this, and this is going to work. We're going to be storing in names and addresses, and this can really work. You see that we can loop through our collection here, printing key and value information, and this is going to work pretty well. We have a bunch of iterators we can use with STD map. We have forward iterators, and we can use them to loop through our container. We have reverse iterators, and we can use them to loop through our container. We also have a bunch of capacity methods we can use to query for the size. We can check and see if our collection is empty. We can also get the maximum size. You already know these things. We can modify our collection. For example, we can clear and see that it has become empty right here. We also have the option to insert data in our collection. For example, we can call insert and see that we are not adding a duplicate. And if it's not a duplicate key, the data is going to go in. But if we happen to add a pair with a key that is already in, that's going to fail, and you will see that your insertion is going to be ignored. But just like STD set, we can check and capture the result of our insertion, and we will know if the insertion was successful or a failure, just like we see right here. We can also in place, and again, the logic is the same. After in placing, you will get an STD pair back, and you can do the check to see if the in place was a success or a failure. We can also erase, and before you erase, you need to find the iterator to the element you want to erase. Once you find it, you're going to call the erase method, and the element is going to go away. We can also change our ordering callbacks. Here you see that we can use the default, and this is going to be using the std-less functor by default, but we have the option to put in ours just like std greater here. We can use a custom functor. For example, here we are using int comparator. We can use the function pointer. We can even use a lambda function, just like we saw for std set. This is really the same things. This is going to work, and you will see that this is pretty cool. Now that you know these things, I am going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is STD map. We are going to grab our template files and put them in place. Let's copy the code. We're going to put that in our project here, and then we're going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean it up a little bit. We're going to remove what we don't need here. We're going to include our map header. We are going to put in the code we're going to be using. We're going to set up our book class, and we're going to put in our comparators. One is going to be a functor, another is going to be a regular function. Down here we will have our book class, which is going to have a less than operator that we're going to be using for ordering. We have an output stream operator, which is going to print book objects. And down below, you see that we have a print map function, which is going to take two template parameters and forward them to be used as key and value information for our map. Inside the body, we're going to be looping around using begin and ending iterators, and we're going to be printing each element at each iteration, going through these iterators here, and this is going to work really well. Now, I am going to go in the main function and put in all the code. We're going to run the code and try to understand what is happening, because this is really similar to what we saw with std set. So I don't want to spend too much time here because you already know these things. So we're going to see how we can create STD map objects. You can see that right here. We're going to create a map of intent book as you see right here. And we're going to be printing this information and seeing the results of the code that we set up here. I think this is a good way to go about this. Let's pass this through our compiler. We're going to be using GCC. The bold is going to be good, so we can bring up a terminal window and clear and run Rooster. And when we do that, we're going to go to the top and see the output we get by creating maps as we see here. We're going to create a map of int and we're going to put in the data, and then we're going to call print map to print our numbers. If we do that, we're going to see that we have our map. And one thing worth noting is that the data has been ordered in ascending order. You see that the element with the smallest key was put first, and we are increasing as we go to the right. You see we have a 0, 1, 2, 3, 4 as key data, and we are ordering our data in ascending order by key. You should really know this. So STD map is going to order its data by key information. You should remember this. Down below here, you see we have another map which is going to have integer keys and book values. We're going to put in data. You see that the keys are not ordered. We have 2, 0, and 1. But when we print the books collection, we're going to see that data has been ordered by key, and the pair with 0 key is first, the pair with a key of 1 is second, and the pair with 2 as the key is coming last in our collection. And you see that data is ordered by key in our collection here. This is something I want you to be aware of. If we go down, we see that we have different ways to loop through our collection. We can use the auto syntax with square brackets as you see here, and this is going to work. You see that we have our data printed down. We can use C++11 loop syntax, and if we go down, you're going to see that this is also going to work right here. We're going to be printing our book information, and we can use this syntax here. That's also going to work. You can choose whatever makes sense for your application. If we go down, we're going to see that keys can be anything. So we're going to set up a map that takes STD string keys and STD string values. This is going to work really well. So we're going to order our data by key. So we will be ordering our data by key information, and the names here are going to be our keys, and the addresses are going to be our values, and everything is going to work really well. If we print, you're going to see that the data has been ordered in alphabetic order. Daniel is first, Henry is going to come second because he is following in alphabetical order. John is going to come next, and then Steve is going to come last. Because Steve comes last, comparing to the other names that we have here, our data is going to be ordered by key as you see. If we go down, we're going to see a bunch of iterators we can use. We can use forward iterators, we can use reverse iterators. If we go down, we're going to see that with forward iterators, our data is going to be ordered in ascending order. It is also possible to modify our elements through iterators. So we can loop through our collection and changing values at each key to 222. And if we do that, you will see that that's going to be our output here. This is working exactly like we want. It is also possible to loop using reverse iterators. And if we do that, we will see that our books are going to be printed in reverse order by key. So 2 is going to come first, 1 is going to come second, 0 is going to come last. We can also use a bunch of capacity methods. For example, we can get the number of elements, and that's going to be given to us by the size method. You can see that we have 5 elements in here. The map is not empty. We have our max size, and we can print our collection to prove these things here. You see that we have 5 things in our collection, as you see in our output. We can use a bunch of modifier methods. For example, we can clear our collection. We're going to print the collection before we clear, and then we're going to clear and print it again, and then we're going to see that it is empty, as you see right here. We can use our insert method to insert a new pair in our collection. What we're going to do, we're going to set up a pair of numbers, we're going to print it, and then we're going to insert another pair. But if we insert something with a key that is already in, the insertion is going to fail. And if we insert something that isn't already in the collection, and by that I mean the key, the insertion is going to be successful. And it is possible to check the result of our insertion and know if the insertion was successful. So we can see all this information here. So you can see that this is our data, and we already have an element with a key of 2. But if we try to insert another pair with a key of 2, the insertion is going to fail. And you're going to see that we just have one element with a key of 2. So the insertion was a failure. But if we go down and insert 6 and 17 here, this is going to be a success because we don't have a 6 key, and we can prove that here. So you see that the result is true here, so the insertion was successful, and we can see our element with 16 at the end of our collection because the key is greater here, and our data is going to be ordered by key in our STD maps. We can also in place, and you're going to see that this is going to work exactly the same. If we in place a pair with 7 as the key, this is not already in, so this is going to be added up to our collection. And we're going to see it right here. This is really cool. It is possible to also erase from our collection. If we target the 3 element with our iterator here, the iterator is going to be pointing to this element, and we are going to find it. We're going to see that the data is 14. We can see that right here. Now we're going to remove it using the erase method. And you're going to see that after we remove it and print, the element with a key of 3 is going to go away, and you see that it is gone in our map right here. So we don't have a key of 3 because we just erased that using our erase method. It is also possible to change comparators. So for example, if we use the default, this is going to use the STD less functor by default, just like we saw for STD set. So our data is going to be ordered in ascending order. You see that we have 0, 1, 2 by key. So this is going to work really well. And it is possible to explicitly specify a functor which is going to be working as our comparator. And again, this is also going to order elements in ascending order by default. So if we build again and change the comparator here, the build is going to be good, so we can clear and run rooster. And if we go down, we're going to see that elements are ordered in ascending order. I think we can put a message here to try and separate these things out. So we can say stdc out stdendl, and we're going to say changing comparators. And this is going to be much easier to follow on the console. Let's build again. The build is good, so we can clear and run rooster. And if we go down, we're going to see that our data is ordered in ascending order by key. So 0, 1, 2, 3, 4. These are our keys. We can also use a custom comparator, which is going to be different from the default. So for example, we can use std greater, just like we did for std set. This is going to order our elements in descending order. Let's pass this through our compiler to prove this. So the build is good as you see here. So let's clear and run rooster. You see that our data is ordered in descending order. We have 4, 3, 2, 1, and 0. This is really cool. We can also use a custom functor, which is going to be comparing using the less than operator, and elements are going to be ordered in ascending order again. If you want, you can go to the top and find this comparator. It is nothing complicated. It is just a custom functor, which is going to set up a function called operator, which is going to compare 2 parameters and return the result of the comparison as a Boolean that we can use right away in our C++ application. So that's what we have right here, and this is going to order our elements in ascending order. Let's pass this through the compiler again. This is going to build successfully, so let's clear and run rooster. We're going to see that our data is ordered in ascending order. If, for example, we want in our comparator and change the sign a little bit, our data is going to be ordered in a different way, and things are going to be ordered in descending order. Let's build and show you that, because you really should play with us and see the behaviors The build is good. Let's clear and run Rooster. You see that things have changed because our comparator has changed the sign. This is going to change the order things are ordered in. Let's turn this back to less than because that's going to be much easier to follow. We can pass this through the compiler and make sure we have no boo-boos in. The build is good, so let's clear and run Rooster, and we have ascending order. This is really cool. Let's go down and see how we can use functors and lambda functions, or I should say function pointers, because that's what we're going to look at right now. We can comment this out and pass a function pointer as a callback. And once we do that, just like for std set, we will use the ability to initialize with braced initializers as we have here, but we have the option to insert explicitly, and this is going to put our data in. So if we build and run, we're going to be using this function pointer to order things, and if we go on top, we're going to find it in our C++ program. It is right here, and again, it is going to compare using the less than operator. So this is going to order in ascending order, and that's what we have right here. So let's pass this through our compiler again. The build is going to be good, so let's clear and run Rooster, and we will have our things ordered in ascending order. We can also use a lambda function using the exact same syntax we saw in the last lecture for std set. So let's uncomment this. I want you to see this explicitly. And then we're going to set up an std map and specify the type for the key and the type for the value. Then we're going to specify an std function which is going to be used to order things. The std function is going to return bool. It's going to take two parameters that it is going to compare, and we pass our std function object as a parameter here, and this is going to work really well. So let's make sure you see that. This is our lambda function. You can pass it explicitly like this, or you can store this lambda function in a variable and pass that variable. This is going to work really well. But you see that we have a bunch of squiggly lines, and this is because we don't have the functional header included, just like in the last lecture. So let's include that. And this is going to take out our squiggly line. If we go down, we're going to see that the error is going to go away. Let's scroll all the way to the bottom. We're going to find our code here, and you see that everything is working now. Because our lambda function is using the less than operator to compare, things are going to be ordered in ascending order, and we will have the same thing we have here. So let's pass this through our compiler. The build is going to be good as you see here, so let's clear and run Rooster. Things are going to be ordered in ascending order. But if we go in our lambda function, for example, and change this to be greater than, this is going to order things in a descending order. So let's pass this through our compiler to see this. The build is good, so let's clear and run Rooster. We're going to see that we have data in descending order by key. So 4, 3, 2, 1, 0. This is what we expect. This is really all I had to share in this lecture, showing you how you can use std map. The defining feature of std map is that it stores data in key value pairs. It is going to order the data by key by default, and you need to have a comparison operator for whatever you use as a key. And just like std set, std map doesn't support duplicate keys. If you try to store in a duplicate key, the std map is going to ignore you and just keep in one instance of that key, because that's how it works. You have the possibility to change how your data is ordered by either changing the less than operator of your type that you are storing as key information in your collection, but you can also change the callbacks that you pass to the map as you create it. As we saw here, we have many options. We can either use functors, we can use function pointers, we can use lambda functions. You can really use whatever makes sense for your C++ application. We are going to stop here in this lecture. In the next one, we're going to learn about multi-maps and multi-sets. And these are versions of std map and std set that allow duplicates. Go ahead and finish up here and meet me there.